Hi, a viewer called Anthony asked would I be to have a look at this GB70 NOCO boost pack, and what he said was the voltage regulator inside getting hot. It does actually turn on briefly, but then kind of just fades out there, as you can see. So how do we get into it? I think there's about 6 screws on the back, and I'm not sure what type of screws they are. I'll just see if I can find a little torch just to have a look. And they appear to be some kind of triangle shaped screw. I'm just wondering if I can get a flat blade screwdriver across those. Let's just see what I've got here, see if that'll work. Let's see if that'll come apart now. I'm just going to move these crocodile clips out of the way. Let's put this to one side. That's the screws there. I'll just zoom down a bit so you can have a look. Like a triangle shape. Now I have got a fitting that fits those, but it wouldn't actually go down these holes here. They're not quite long enough, but right, let's see how this comes out then. Looks all a bit just shoved in here, to be quite honest with you. Let's just hope we don't short anything out here. Unplug this plug here, unplug the relay board. So we can get this board out, I think. I can see a screw just down here, so we'll take that one out. There's one over here, and is that it? Another one hiding under here. I'll try and find these screws in a second. Let's get this one out of the way. Looks like there's supposed to be a screw in there, but he's already taken that one out by the look of things. Now, why won't this board come out? Seems to be stuck on that bit of plastic there. There we go, I just moved. Right. So what have we got in here then? I'm gonna have to be careful of this lithium battery here. Right, let's just zoom down on this board a bit, see if we can see anything obvious. Well, I can't see any signs of any exploded components or anything. It looks like we've got a voltage regulator here. And another one there. So what I might do is just plug it back in. We'll get the thermal camera out to see which regulator is getting hot. Right, I'll just zoom out a bit. Let's plug some of these wires back in. Just carefully making sure that we're not going to short anything out. I think you better do it that way. Right, let's try and get that set up like that. Right, so let's go and grab the thermal camera. Right, got the thermal camera. I've actually got two now. So this is the original KTI W02 that I've been using on the channel for quite some time now, but Kuwait have actually sent us the updated version, which has actually got the same model number. Now the difference is with this one, it's got some upscaling on it, so the sensor, which is 256 by 192, is actually being upscaled now, so it gives you a better resolution. It's also got Wi-Fi and a few other features, and it records video now, whereas this one only took pictures. This one does video as well. So we'll give this one a spin and we'll see how we get on. Right, so where's the power button on this thing? There we go, there's the on off. So let's just start this in recording mode. Let me see it's recording there now, so I'm going to press the power button. And it looks like we've got some components getting hot just about there, which is that voltage regulator. It's cooling down now because it's switched off, but if I switch that on again, yeah, we can see that getting up to 140 degrees almost. And it looks like the main chip's heating up a little bit as well. Not very much though. Let's just see if there's anything else on this board. Right, so it looks like there's a problem around this voltage regulator. We'll get the thermal camera out of the way then. I'll just switch this off. Stop it from recording. There we go, saved. This one's got internal memory as well, whereas the other one took an SD card. Now I don't know if that's an advantage or a disadvantage. I mean, myself, I like having an SD card in here. But this one's just got the USB-C socket now. Whereas the other one, that's where it took the SD card as well. So, made a few improvements. Like, if you want one of these, there's some links in the video description with some discount for viewers if you're interested. Right, let's get the test meter in shot. Let's get that out of the way. I'll just go into ohms first. Just want to see what's going on around this voltage regulator. Try and get the meter in shot a bit more there. So let's just try. Well, there doesn't seem to be any shorts or anything across there. On the ins and the outs, let's just try across this capacitor. Ah, hold on. 7.5 ohms does seem a little bit low. Again, we've got a diode there. So I guess that's after the voltage regulator. Yeah, 7.3 ohms does seem a little bit low. Let's just hope it's not this main IC here. Right, how am I going to tackle this then? I think the best thing to do might be to find which side of the capacitor's ground, and then we'll try injecting some voltage with the bench power supply. So I'll disconnect it from the battery pack. We'll get the battery pack out of the way the best we can, and then we'll try injecting some voltage with the bench power supply. Right, I'll just go and tag a couple of wires on this. Right, I've tagged a couple of wires onto this capacitor here. That's the ground side, and that's the positive where we're going to inject 1 volt at 1 amp. And I've got the thermal camera ready here. So we'll just switch this on. I'll set this recording. And let's see what gets hot. Well, there's something getting hot there. I'll zoom out a fraction here because it's a little bit hard to get everything in shot here. So we've got two things getting hot. One's the main chip here, and another component just here. Looks like that diode. So I'm just wondering if the main chips failed on this. Right, I'll switch this off, and I think we'll get this under the microscope, and we'll pull that diode off, I think. Right, I'm just going to add some fresh solder to this first. Let's just see if I can get in a bit of an angle and see if I can just pop this off. Right, I'm just going to put some low melt solder on this. It should make it easier to remove it. Right, let's get that out of the way. Let's just see what we're measuring now across this capacitor. And it still looks like we've got a bit of a short there. Not as much though. I'm just going to try this diode. Well, the diode's shorted. Well, there's obviously something else as well. Let's hope it's not this main chip. So let's just see what that chip is. It is a Holtec. It looks like HT50F2E. Well, we've got a 3.3 volts there. And let's just use this as a ground. And we've still got 12 ohms. So that's not looking good, is it? Right, I think I'll inject some voltage again and then we'll see what's getting hot again. Right, I've got it hooked up with the bench power supply again. And I'm injecting 1 volt at 1 amp. And it looks like the only thing that's getting hot now is the main IC here. Right, I'm going to look up that part number, see if I can find a data sheet, and we'll see what this IC is. So I couldn't really find a lot of information on this chip on the internet, apart from this EEV blog post, where somebody else was repairing a GB70 jump pack as well. But unfortunately, they came to the conclusion that his microcontroller was blown. So I'm just wondering if it's the same thing on this. I've got a strong suspicion that's what it is. So what I might do is just try and remove this little subboard here, and we'll see if the short goes away. But I just want to try a couple of other things first. So I've got a 3.3 volt Zener diode here. It's a through hole one. But what I'm going to do is just temporarily solder it onto this, and we'll just try powering this up just to see exactly what it does. So I'll solder that one there. I'm just going to add a little bit of flux to that first. Just to make it a little bit easier to solder. Something a bit like that. And that's not touching that other thing, it's actually a lot further up, it's just the angle you're looking at it there. Right, let's get the microscope out of the way then. Let's see what happens when we hook the power back up to this. See if it still fades to green. Oh. Well, it's actually doing a bit more than what it was doing. I've actually got some power lights on there. Let's just see if the torch seems to work. Well, it's definitely doing more than what it was doing. But I want to see what that chip's doing. So I think that chip's still faulty. I think one of the outputs or something's gone on it. Let's have a look. Let's wait for the thermal camera to come on. And that chip's still about 60 degrees, which I don't think's normal. The voltage regulator is still heating up as well. I mean, surely that microcontroller should be up to 60 degrees. Well, what we could do is connect it up to a car battery and just see if it sort of boosts it. But I still don't like the look of that. I think there's a fault with that microcontroller still. Yeah, it's only up to 70 degrees now. I mean, I don't know what these chips are supposed to run at, but it just seems a bit high. Just seems a little bit high to me, that. Right, how do you switch this off then? And it doesn't appear that it's switching off either. Again, that sort of points to the microcontroller. It looks like the processor part of it's running. I'm just wondering if there's something up like one of the I/O pins or something like that. I've actually got the main battery wire disconnected from the board at the moment, just while I was working on it. So I might connect that back up. We'll plug the relay lock back in, we'll see what it does, but I'm pretty sure that microcontroller's a bit fried. Yeah, when you put your sensitive part of your finger on there, it's a bit warm. Right, I'll solder that wire back on. I'll connect this back up and we'll try jumping a car battery. But the fact it's not switching on and off as well, which will be sending a signal to the microcontroller, I'm pretty sure that's fried. Right, I'll sort that out and I'll be back in a moment. Right, I've got a car battery here, so what I'm going to do is just connect it up a second. Actually, I'll plug these connections in here first. I'll connect the car battery up. We'll switch this on. I just want to see if the relay sort of clicks in. So I would have thought it should have done something by now. You should have heard the relays click, and it isn't. I think if you hold the boost button down, it should. Well, that doesn't seem to be doing anything either. And one thing I've just noticed as well, thinking about it, this green light pulsing like that. That's normally what it does when it's charging. But there's nothing charging it. Again, it sort of points to the microcontroller to me. So I think what I'm going to do is remove the microcontroller and we'll see if that 12 ohm short disappears. Because that's pretty much what I think the problem is now. I think it's this microcontroller's gone. And this part number isn't even listed on the Holtec site. On the EAV blog, they think it's a custom part. And even if you could buy the chip, we wouldn't have the program to program into it. So we're not going to be able to repair this one. That's it pretty much, if it's the microcontroller. So what I'll do, I'll disconnect it again. I'm going to put some low melt solder on here. We'll take this microcontroller off and then we'll measure to see if that short's disappeared. Desolder that wire again. I'm just going to put some tape around it. Just so it doesn't short anything else out. I'll disconnect the relay. Right, so I'll get this back under the microscope. And we'll take this chip off and then we'll see what it measures after we remove the chip. Right, just going to take this diode back off. And put some flux on here. I think I'll put some low melt solder on this first and then use some hot air. Oh, it might just come off with the low melt, we'll give it a go. Right, that's the IC removed. I'll give these pads a clean up. I'm just using a bit of isopropyl alcohol here just to clean these pads up a little bit. Right, let's see what we get between ground and this 3.3 pin now. So which one was the ground again? Let's just go on to resistance. Right, so that's the output, so that's a 3.3 volts in, this side's the ground. And we've got K ohms now. So the short is gone. If we measure across this cap here, 5.9K. So if I get this little module, let's refocus the microscope. I might have to clean some of those pins up, but I don't think it'll really matter. So let's just measure between, let's just measure across this cap here, because that should be across the supply, and there you go. 13 ohms. So unfortunately, microcontroller's fried. Well, we know what the problem is, but unfortunately we can't fix it because we can't get the part. And even if we could get the part, we haven't got the program to program into it. So, no fix on this one, unfortunately. At least we found the problem and we know what the problem is, but we can't fix it. So I'm going to have to leave this one there then, unfortunately. Right then, if you enjoyed this video, give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.